Okay. So, okay, me missing, but never mind. Shipborne Radiometry. So ISFRN stands for the International Shipborne Fiducial Reference Measurement Network. My name is Werenfrid Wimmer. I work at the University of Southampton, and I'm the chair of the Shipborne Radiometry Task Team. There's currently no co-chair, so I'm open for volunteers. I'm presenting the talk, yes. So there's a current list of members. I'm sure there are a few more people, but that's what I have on my list. If anybody's interested, please talk to me. Purpose and main objectives of the task team were building a collaborative network, dataset format and DOIs, best practices, and an archive for the dataset. Disclosure, it's ongoing. However, I would say the main objectives probably have been achieved, but there are some ongoing things which I get to in the talk while we're still open. So the building a collaborative network, that's ongoing, expanding data set, getting all the people who do these kind of measurements from infrared radiometers together, and also the data users, and have a common platform for that. So what we've done on that, I've missed the main point here. Actually, we had a big workshop in April in Southampton for all the people who do this kind of activities. And there were 2 days of talks and presentations on that. If you go to the GHRSST webpage, you can see what we've done there. We were part of an EarthCare validation campaign. We're also, normally the data is used for the Sentinel-3 A and B validation campaigns, but that was a specific extra activity we did. Expecting outputs, yeah, expanding the FRM dataset, we do that, and lots of spelling mistakes there. I'm trying to get a validation paper published to show our activities and what the data is used for. The common data format, you have the names up there, and it says mainly completed, but we have a common data format. There's a description document on the GHRSST webpage, and why I said mainly completed is because with the data archive, there's some ongoing minor issues, and that might lead to change to the data format. But at the moment, it's based on a GHRSST L2R, it's called, but it's very similar to the GHRSST L2P format, but it's slightly modified for ship track and these kind of observations. And Tim has done most of the work on that. That's why he's the task lead up there. So we have that is CF compliant, and Jeff and Igor have checked it. It works quite well. We have the data format document on the GHRSST webpage and the data format converters from, if you have a ASCII format, you can put it into that L2R format, relatively simple with a Python script. And I said for activities in the 12 months, simplify the data access for Felix. Felix is the big MDB program at EUMETSAT, and there are some minor glitches with running it more frequently. So we would like it to run more frequently than it is currently done, but that's up to discussion. And the data archive, there's more people involved in that than Jean-François, but he's the team lead because he works at ISFRN and looks after our archive for us. And the data archive is functioning. If you go to the GHRSST webpage, you can log in there and download the data from ISFRN. There are the slides from the data archive. So this is the GHRSST data on the ISFRN data archive. This is an SST. It's slightly Atlantic based, but that's because the way we run the ships, or the ships we allowed have access to. And if you look at that, that's split by data operators. At the moment in the archive, blue is Mary data from University of Miami, Peter Minette. Green is sister data from Rutherford Appleton Laboratory in the UK, run by Tim and Arrow. And red, dark reds is my instrumentation at the University of Southampton. The slightly lighter red colors in the north is the DMI instrumentation, and family color is CSRO data around Australia. And this is why we have some minor issues in the archive. It's done like GHRSST data. On the left-hand side, you can see that there's the data providers in the different colors again, and then there's version numbers of the data processors. And we learn new things, so the data processor gets updated depending on instrument more often or less regular, but that makes a little mess in the archive for our main data user, Felix MDB, and makes it more difficult for them to access the data. You can also see that some data has been since 2004, some has been a bit more recent. This plot shows the updates to the database since last year. So on the right-hand side is what we had last year in the database. On the left-hand side is what's current end of May this year. And the main differences are in the last few years, partly as a leftover from COVID. It took us a while to get back onto the ships, but also some funding streams for some of our partners have disappeared. So, for example, the Mary data is back in there, but it's back in there because I converted the data to L2R because Miami can't do that at the moment. And also there is some more sister data in there, thanks to our friends at Werenfrid Wimmer. So what we planned in the next 12 months and during this week is actually sort out a simpler access to for the user. They don't have to worry about what's the newest file version. And what data we still have from the COVID leftover into L2R. The expected output is to make the data archive easier to access from a user point of view. What are the challenges? Yeah, the usual fanning and manpower, that kind of interlinked, but and additional points, there's new instrumentation on the horizon. Aston, I'm involved with together with our colleagues at Radiometry Upton laboratory in the UK. We're assembling the prototypes and hopefully we'll have a working instrument by the end of this year. It's a filter radiometer with 8 channels and a dedicated detector and 2-put calibration like ISFRN sister had before. And Andy Chessups has a new instrument running, which is going the other way, make it simpler, easier to deploy. It's a single point calibration instrument with a optimal band detector at 7.7 micrometers. And that's Astern. I have more slides on that, just this one, because I'm involved in that. Was UK funding, is 8 channel selectable. So you have the channels in the top right there. So there are the LSTM channels around 8 micrometers, the split window, 11 and 12 micron. And then the really new thing is a air temperature band at 15 micrometer. It's a modular instrument as a Leonardo detector, and it's based on our experience from Sister and ISER, and there's a schematic of the bottom, and on the right-hand side is the filter wheel as it's being assembled. That's all I have.
Thank you, Fred.
To get to the coffee break, please.
Eager to get some coffee, I think.
Yes.
Well, let's see if there's one question or comment.
No questions. No questions. Oh,
there's
one.
Andy in the back.
I looked up from my laptop and saw this and wondered, why 8 channels? Do you think? Is it because you want to study emissivity particularly, or what? Because it's not like you really have a big atmospheric correction problem.
Why 8 channel is because the instrument is also developed for land users, and they want the extra channels, yes, for emissivity, and that's why you have the 8 micrometer 3 channels there for LSTM validation.
All right, okay, right.
That's why it's there for land. We only wanted the air temperature channel on for sea application. But it's an instrument which fixes all your problems and generates a couple of new ones.
Okay, sounds excellent. Thanks, Fred. Oh,
Igor.
We're time for another question.
Later.
Oh, go ahead.
Thanks, Ed. Igor here from UMSET. So just related to archive, we discussed before, and we suggested to reorganize a little bit how the data are stored in archive to use. Yeah, so basically this is the main issue why basically our SLSTR and Radiometry MDB delayed.
Hopefully we'll discuss a way forward this week, and then we go with that.
Thanks.